So let's define our framework. So we start from def init. We start from class, right? Class neural network building. You can see neural network model, right? So take in nn.module. nn.module is a class already. So this nn.module is I explained when we are looking at object programming, where we have the parent class and the child class, right? So this is an example of a class inside a class. A class inside a class. So we're having nn.module as a class. nn.module is neural network. We have imported it before. See, we said import touch.nn as nn. So this is neural network library already. So we say nn.module, then we'll say def.init, right? It takes in the value of self, remember, and then we'll say super.init. So the reason why we use this was because we want if we did not put this super open brackets / init this our class that we are defining will not allow the parent will not adopt some things from the parent class, or the parent class can override the class we are building. So this is trying to say that don't override any class, right? It is trying to say that, okay, I want to use some properties in this class, and I also want to build my own properties. So that's what it's saying. There's a property in this class already that we are putting inside this class we are building, right? So that's what this is saying. So then next is, maybe you want to use remember, you can use random underscore state, right? Random underscore state 42 or whatsoever is you trying to say, okay, reproducibility, so that when you run the code over and over again to give you the same thing. Set.seed is using R. We can also use touch.manual underscore seed, right? So I can say touch.manual underscore seed. I can say 45 or 43. This is to make sure I can reproduce the code over and over again. So what are the things that I'll be needing? So let's assume I want to build a neural network that has 48. So first thing is to check how many x do you have? How many x do you have? Independent variable. You have how many? This is the shape is row and columns. So columns are the x, right? So how many x's do you have here? 48. So how many y do you have?
10,000. How many y?
Yes.
1 now. Y is target.
Yeah, good. Y is 1. Joy, are you there? Are you there, Joy? Okay. Is she on the commercial? Because I can't see the.
Yes, she's on the call. I think her network.
Oh, okay. So x, we have x, the number of the independent variables we have. If you check the independent variables we have in this case, for instance, you see that because this have been converted to PyTorch. So if you check this s, let me run this. You can see, so we have 48 of them, and we have just one y. So let's build a neural network that has 48 is the x, just one y, but the number of layers we have. So let's say we have 3 layers, and each of these layers, let's say the first 3 hidden layers, right? So I'm building it. The neural network I want to build now is a neural network that have the independent variable that we have, which is this, like this, x x x x x. So they are 48 in number. We have 3 hidden layer 1, hidden layer 2, hidden layer 3, right? And we have the output. So the output is just y, which is 1. The x is 48. So the first hidden layer, we have 96 neurons or nodes, right? The second hidden layer, we have 192. The circle that you can see the network is very big. And you know, when you did the calculation, that simple one, you can't do it here because you'll be exhausted. And the third neurons, we have 384. So we have a neural network where x is 48 and y is 1. And the hidden layers we have is 96, 192, and 384. So with that we are going to build our network. Okay. So let's do that. So self.rc1 can be anything, right? Self is just more like a place value. n.linear. So neural network.linear. So linear what? The first thing is 48. 48 will go to what? 96, right? So it's from here. 48 will go to the next one, which is 96. Then 96 will go to what? 192. 192 will go to what? 384. 384 will go to what? Just 1. So that's the first framework we are building. And then the second framework is that we are now saying we have move. We want it to move. The first framework we are just doing is just building the framework. The second one is saying let it move. That's why we're using forward. Alright, so self.rc2 nn.linear, that will be 96 to what? 192. Next is self.rc3 equals to nn.linear, right? 192 to what? 384. Next is self.out. You can call it out because that's the one going out to the output. It can be called anything. Anything here is just a variable, right? The linear 384 to 1, right? So self.find now nn. We'll need sigmoid, right? Because the sigmoid is the one that will take. So most times we use ReLU activation function here from the inputs to the hidden layers. Most times we use ReLU, right? Because ReLU just pick the max of 0 and x, so it is computationally efficient and it converges very, very quickly. So that's why we use ReLU. But from the last hidden layer to the output, most times we use the sigmoid for just 2-level classification, and more than 2 levels we most times use softmax. So I will need sigmoid, right? I also need, maybe I can call this ReLU. I also need ReLU. So I can call this sigmoid. So I've defined the first layer, which is this. Is this clear? Mercy and Joy, is this clear?
Yeah.
Okay, good. Joy, is this clear?
But I have one question.
Okay, you can ask.
So how were we able to know that we are just working with, I think, 3 layers, right?
Okay, so the layers will be defined by you. The more the layers, that's the how the depth of the network. So the more the layers, the better the prediction. But the more the layers, the more computational expensive it will be. The more time it takes for it to converge.
Okay.
So that's why we are using ReLU. in from the input to the hidden layers, because rarely we just pick. Let me explain why we use rarely. You know, for rarely, what you just, let's say you get a value that is 2, so rarely you just say, okay, the max of 0 and 2. So what is the max of 0 and 2 is just 2, so it will report to very quickly. But sigmoid will start with, sigmoid will be doing some calculation as 1 over 1 plus e raised to power minus x. It takes time before you do all of this, but rarely you just say the max of 0 and 2, put 2, but sigma will put in this 2 in x. You now get e raised to power minus 2 plus 1 over that thing. Soft math is e raised to power x over summation e raised to power x. This also takes time, but all of these soft maths and sigmoid and rarely, most times or interchangeably, I use from the last hidden layers to the output. But within this network, from input to hidden, we always use rarely because it's faster. The goal is to build a network that can converge early. Converge early means make the prediction on time, doesn't take time. Sometimes you can run a model that takes the whole day, it can take a whole week. So we want something that can converge very fast because of the depth of the network. Look at this now. Instead of all the network I've been drawing just 2 neurons in the hidden layers, but this time around you have 96 neurons, you have 192 neurons, you have 384 neurons. It's they are trying, the neurons are trying like the connection between the variables. Is that clear?
Yes.
Joy, is that clear? Joy.
Yeah, I'm following, but my video is just freezing.
Oh,
I'm writing the one I can write.
okay. Mercy, is your video freezing?
Like on my two devices freezing at the same time.
Okay.
No, my video is the network actually. But are you making video at least so that she can
Yes, I'm
go through
recording the
again?
class. So I haven't done this, we have done the framework. So let's now move our network. So we are going to move it together, right? So the next thing we want to do now, we have done this. So let's move it. So that's why we use forward. When we do backward propagation is when we want to calculate our weights and biases. We want to get the best weight. But let's do forward first. So how do you do forward, right? So def forward. Forward is a method in this module, in this class. So call it self. Before you take x, because we want to start from x, right? We want to start from x, move it to the hidden layers, and then to y. So OP, you can call it any name, so I want to call it OP. So what's the first thing I'll do? I'll say, what am I moving first? What am I starting with here, guys? What am I starting with? What am I starting with? I want it to move. So I'll start with what?
Self.rc1.
Self.rc1. Thank you. So I'll start with self.rc1. What will it take? It will take in the x values, right? Then I can call another one OP. So what will I need to make it move? I'll need an activation function. Which activation function should I use? I'll use relu, right? This, because it's defined to be this. So I'll use this, right? So what do I put inside this relu? I'll put this variable that I've defined to be this. Are you following? Right?
Yes.
So next is self.relu, self.rc2 op, right? op equals to self.relu op, op equals to self.relu rc3, right? op equals to self.relu op. So from rc3 we are moving to the last last thing, so we'll define it, right? OP equals to self dot out OP, and OP equals to self dot sigmoid what OP. So we can call this Y, because that's the final Y that it will give us, and then we'll say return Y. So I've defined a neural network framework that we'll be using. Is this clear? This is just defining the layers. This is saying that the layers should move. Am I good to go before I continue? Am I good to go before I continue? Is it fine? Can I continue? Can I continue? How it should be. I made a mistake. So is it fine? Can we move on?
Yeah.
Okay. So the next thing to do now is to develop a framework that can train our model. We want to now train the model, right? So we want to train the model, which is very important for us, right? So, and to train our model, right, first thing we want to define a function, and that function takes in something, right? There's a name I call it. Let me see. So the next thing to do is to train our network, right? So you define the function to train your network. So before defining your function, there are some things that will be needed for training the network. Remember, we need to train before we test. So what are the things that you will be needing, right? So there's at least the major things you'll be needing for now before building maybe a more robust model are just some few things, right? So I call it mol ln xyb. Mol ln xyb. So these are the major things you need to train your network. What is the first thing? The first thing is called your model. You need your model, right? The next thing is you need your optimizer, right? So optimizer is when you have the undergrad, the Adam, the momentum, the stochastic gradient descent, how you want to take your step to calculate your gradient. So you need your optimizer, right? So you also need what? You need your loss function. Your loss function can either be the MSE or the cross entropy. Cross entropy is used for binary classification, right? So we have cross entropy and one other one. We have binary cross entropy, which is for binary classification, and we have cross entropy, which is used for more than, maybe not binary, but more than 2 levels, right? So we have MSC that can, and we have other types of loss that you can use, ink loss and the like. So, but you are familiar with this MSC loss, that's summation y minus y hat over n minus 1, right? So you also need your loss function, right, to train your network. Then you also need what we call lambda, right? So lambda is, when I was explaining, lambda is optional though. So lambda is used for regularization to help you handle overfitting or underfitting. Remember, when you have your loss function, the loss function is, let's say, y minus y hat, for instance. You can add another term, which is called this, right, which can be L1 loss or it can be L2 loss. So this lambda will help penalize the error, right? So this lambda is also some things that you'll be needing, but this can be zero, not needed for now. I can make it zero, right? So you also need the number of epoch. So epoch is epoch, that's the number of runs. Like go the first time, understand the network, come back. You want to,
Sorry,
yes,
epoch.
epoch. So let's
Okay.
take for instance you are on a mountain. Is Joy back now? Joy, are you back?
Yes, and I'm back, but my screen is skipping.
Okay, so let's say you are on a mountain. So let me explain this. You are on a mountain.
Are you ready?
Yes, I'm recording. I'm recording. Right. So you are on a mountain. Right. So and the idea is you want to get to this place. You want to buy beans or bread, beans and bread in this shop. Right. So first you want to train your network. You want to train your model. And training your model means you want to be able to know, okay, what is the best route to get down from this mountain. So first you need your model itself, right? You need the optimizer. Optimizer is saying that what steps should I take? Should I go like this? Should I go like this? Should I come down like this? Should I go like this and come down like this? All of them are defined by the type of optimizers, whether it is ADA grad, it is Adam, it is momentum, it is stochastic gradient descent, it is batch gradient descent, it is forgotten the other one, whether it is full gradient descent. So gradient descent in general, that's what you're optimizing is saying. Follow this direction or this direction or this direction, right? So L is saying your loss function. Loss function is saying that how you calculate your loss. So if you come down here, right, and then the best way is actually to let's just assume that the best way is to follow this direction. Or let me use a red line. Let's say the best way is to follow this direction. The best way to get to this point is to follow this red direction. Best, quickest way, cheapest way, easiest way, fastest way to is this red line. So if you follow this black line, for instance, you calculate the error. So you need your loss function, right? So number of epoch is saying that, okay, how many times do you want to go? For instance, if I go from here and I come down, let me use another green line. If I go like this, epoch is 1. I will calculate the loss function. I will go back up. I've seen this way already, right? So I will not follow this way. Maybe when I was following this way, there are potholes. I will not follow this way. I will go again. I will come down again. I will go up back. I'll follow this way. Maybe there are potways. I say, okay, instead of following this direction, there's a smoother way like this. When I'm coming another third time again. So the number of times, most times in neural network, you can see the number of epoch can be 1,000, 5,000. That's the number of times you want this guy to go down and go and understand the road. Are you following? That's the number of
Yes.
input. So we also have the X train. That's your data. You need your, because we are training the model X train. You also need your Y train, right? So and you also need your batch size. So many a times we do not want to train the model all at once because it may so, we are using CPU, except sometimes you change to GPU. So we don't want to do it all at once. So all we can sometimes what we do is, so instead of training the model all at once, let's train them in batches. Let's pick maybe let's pick it 2020 or 5050 or 1010 and train it. But if you pick everything, like some of them, the rows can be 42,000. Before 42,000 we learn and go down, sometimes it may take a lot of time. So you may pick it 42, 42, 30, 30, 30, 30. So that's what is called the batch size. And in this optimizer, we have what we call the
Sorry, what is X and Y
X and Y
again?
is X train and Y train, your data itself.
Okay.
Yes. And then in optimizer we have we call the learning rate. So the learning rate is the step size. Are you taking big step? You want to come down from this part to this part. What is the step you are taking? How big is your step? Is your step big like this? If your step small like this, is it very tiny step you are picking? Intuitively, what step do you think will be the best? Big steps or small step? You are coming down from this part to this part. What step do you think will be the best? Big step or small step?
Big step. Big step.
Small step. Small step.
It will be small step.
I can't see the screen, but it will be better. If you're coming down. If you're
Yes,
coming
small
down.
step will be better because it will you want to be able to see every road you are passing. So if you take big step, you may jump some places that you not see. But big step is faster. It will go down quickly. It will converge quickly. So small step is slower. But then you also want it's a trade-off between computationally expensive and accuracy. So the smaller the step, the larger the accuracy you get, but the slower your network. Are you guys following? So to train your model, these are at least for a start, these are the 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 things you'll be needing. The first one is your model, second one is your optimizer, the type of optimizer and your learning rate. You have your loss function, right? Aside your loss function, you have your lambda, which is the parameters for overfitting. You have your number of epoch, right? You have your X train and your Y train, and you have your batch size. Is this clear before I move on?
Yes. Yes.
So to understand this, to go to the coding, I'll first do a prototype so you can understand what is actually going on. So I'll use maybe 4 variables so you can understand. Is that clear? Yeah. Do you need a screenshot of this? Or you've taken it?
I've taken notes, but just screen is not showing.
Your screen is not showing.
Yes.
She's not though.
Yes.
She's not though. I'm just listening to audio. Then my mind like there's recording. So that's in fact my second device is only your picture that is showing.
Wow. But Mercy, you can see my screen. I'll use a small data set to explain the training function that I want to build. And I'm so glad that you guys understood the neural network framework that we built. So the next thing we need to do is our training function. Right. So for the training function, we have this. Let me just pick an example. Okay, but now can you see my screen better, Joy? Can you see my
Yes, I can see. Yes, I can see. Yes.
Okay.
Yes, I can say table with 2 rows and 3 columns.
Yeah. So let's assume this is X. Remember the X we have is 48 in number, but let me just pick 2 and let's assume this is Y, right? So so let's call this 1 1, let's say yes. 2 1, let's say no. 1 1, let's say yes. Right. So the very first thing is to define your function. So you define your function, right? And the function should take in, maybe you can call it train network or something. So the function should take in those things that I mentioned, right? M O L L, right? M O L L N X N X Y B. This is everything that the function will take, right? The first is, let's try to know them. The first is your model, optimizer, your loss function, your lambda, your number of epochs, your X train, your Y train, and your batch size. So right, so having done that, the next thing you want to do is, let's say you want to have a placeholder that can hold your loss. Let's say you want to plot it later, so you can just call it maybe loss holder, like hold my loss for me, because the loss is very important. You want to see how the loss reduces over time, right? And so you would want to say, okay, you want to use your for loop now. So for epoch, that's what you start for anytime you are training. Or you can say for I. Let me start for I. For I in the range, right? The range of what? Remember, you need the number of epoch. So the first thing you want to put here is n, because the number of epoch will be defined later. Maybe I want to go into 500, I want to go into 300, I want to go into 700. So for I in the range of number of epoch, the number of epoch is just anything I'm saying now. Just be imagining you on a mountain top and you want to come down to buy bread and beans. So the number of epoch is how many times you are moving from the mountain top to down. That's how many times. You know, the number of times you move, the number of times you understand the road. It's like the number of times you solve a past question, the better you are, right? Right? Right?
Yes.
Yeah, so
Yes.
we have picked
Yes.
one now, number of epoch, right? So we want our train loss. So yeah, the train loss we'll be looking at start from 0. The train loss is different between their prediction and the actual, right? Train loss is y minus y hat. That's the first thing we want to do. And then we want to now tell our model, yeah, model, and you need to understand that what I want to do now is model.train. I want to train my model. So we'll say model.train. This is to tell the network that we want to start training our model. When we want to start evaluating our model, testing, we'll say model.test. So we'll say model.train. I want to start training my model. Right, so having done this, so the next thing you want to do, you've said, okay, model.train. So you want to now start with the batch size. Remember, the batch size is that instead of using this data all at once, all I want to do is I want to pick it. Let's say I want to pick it. Let me put one more data. 2, 4. Let's say no. So instead of doing the 4 all at once, so
Sorry.
yes.
Sorry. Please, give me a minute. I'm coming.
So instead of using all of the 4 rows at once, the 4 values at once, because this might take time. You know, this I'm using CPU, it may be computationally expensive. So I can do a batch size. I can pick it. I can do 2, right? I can do 2, I can do 1, right? So that is the idea. So, and then to define that, so what we need to do, we need another for loop. So I'll say for I in the range of what? So I want to start from 0. Remember, when you say range of 0 to 5, what you have is 0, 1, 2, 3, 4, right? Because this will be n minus 1. But when you say the range of 0 to 5, difference of 2, you have 0, 2, 4. You stop here. 0 to 4, right? 0 to 4, you stop here because of you are saying that difference of 2. So that's range. Okay, so we want
I thought the 2 was going to be.
You thought the 2 will be what?
Will be behind 4. Or is it not the same as what you thought was 2?
Which one? This one? No, the range of 0 to 5, difference of 2. Meaning that we are starting from 0, we are going to 5, the difference is 2. We are starting from 0, we are going to 5, the difference is 2. So 0, 2, and 4, the difference is 2. We can't say 6 because 6 is not part of what we are looking at. Do you get it? Do you get it?
Yes, I'll help. Maybe I get it. I'll still have to review the video.
Okay.
But Messi is not yet on the call.
Yeah, she said we can continue.
Okay.
So the range of 0 to what? Where are we going to exactly? So we are going to we are going to the total, right? The last, because 0 to 5. So what's the total? 4. So instead of saying 4, instead of just saying 4, because I may want to use this model over and over again, so I can't just define 4. If I define 4, if I increase my data, let's say I got a new data and it is 6, I can't go back to the model and start increasing to be 6. I can do that manually, but it's not okay as a programmer. So instead of doing that, I can say the X shape. I just say if this data is defined as X. So if this data is defined as X, this is our X string, which is this X string. So I can say the X dot shape. And if I say the X dot shape 0 means, if you say X dot shape, you have something like this. You have the number of rows and the number of columns. So when you say 0 will pick only the rows. When you say 1 will pick the column only, instead of just having row and column. So I say X dot shape 0. I mean that I don't want to just write 4. This will also still give me 4, because the dimension of this will be row by column. How many rows do we have? We have 4 rows, right? And X string is just this. Y is not included. So 4 rows and 2 columns. We have 4, 2. But I just want to pick the 4. So I'll say 0. I'll put it in square bracket. So instead of just writing manually 4, I'll just put this so that in case I increase. So I'll put this, and I'll put the batch size. The batch size is okay. The batch size, which is B. So I've used this also. So I've used batch size, I've used X string, I've used number of imports. So the batch size is saying that, for instance, if I say 0, X shape is 4, and the batch size is 2. If I define the batch size is 2, meaning that what you should have here is 0 to 4, difference of 2. So I have 0, 2, and what? I'll stop at 0 and 2. 4 will not be included, because remember that the last part is not always included. So I have 0 and 2. So meaning that I'll just go 2 times. Meaning I'm going 2 times. So meaning I'm going 2 times. So it's telling the network that what you are doing now, instead of going once, you are going 2 times. So I haven't done that, right? So I need to define what my input data is and what my labels are. Input data are the features. That is, they are the independent variable, and what's my dependent variable. So I can call this my input data. So I can say features or independent variable, or let me say independent. So independent variable and dependent variable. Dependent variable is what we want to predict. So the independent. So how do I define my independent variable? So my independent variable, what I'm looking at is, because this is batch, so I'm looking at X string. The X string, what I'm picking is pick I, this I, right? I'm doing slicing, then the minimum of X train shape, this, the minimum of X train shape, which is this, right? And I plus the batch size, I plus this batch size. So do a slicing between the two. So X train I, minimum of this and this, right? I'll explain what this is. The same thing with Y train. So y train I dot the minimum of what? The minimum of the y train shape, right? The minimum of the y train shape in this schema, because people are looking at y train. The minimum of the y train shape, then the dot shape, the shape should be 0, right? And I plus the batch size 2. So why are we doing all of this? So we are doing all of this because so let's pick this. So let's pick a batch size of 2. So for I in 0, the x shape is 4, and then the batch size is 2. So we are saying that we are going 2 times, right? We are going 2 times, that's 0 and 2. So the first thing is your features. What is the feature? The independent variable. So let's do what is inside. What is inside is I. Let's pick the first one. So the first I is 0. The first I is 0. So it means that the minimum of 0, you are doing slicing now. 0 dot the minimum of. So what is the minimum of I is 0 in this case, and the batch size is what? The batch size is 2. The batch size is so it's I plus the batch size, that's 0 plus 2, because the batch size is 2. We are saying batch size, we want to go pick it to 2, pick it in twos. So we have the minimum of 0. So we have the minimum of 0, 2. And what's the minimum of 0, 2 in this case is 0. So it is 0. So meaning that 0 slice 0 is 0, right? Meaning that 0 slice 0, and then there's an x train outside. So there's an x train 0. So x train 0 means pick the first column, right? So we pick the first column from this. So from the x train we pick the first column, which is this, which is 0, and it picks just the 2. I don't want this to be confusing, but I want you to understand it. If you don't get it, let me explain again. Is that clear? Do you get it? Do you get it?
Yeah, I'm still following.
Okay.
I'm still following. Probably you would have to explain again. Because I wanted to ask a question. At the time you're using batch size, I was expecting that a number is supposed to show in the batch side, but you already mentioned 2. And again, in slicing, I think you taught us that we don't include the last number when slicing. I'm not sure.
Yeah, I didn't include the last number here.
Okay.
I said from 0 to 4, difference of 2. So if you are saying from 0 to 4, difference of 2, what I mean here is in terms of range. Now what I mean, I'm saying 0, the next one should be 1. It won't be 1 because I'm saying difference of 2. So the next thing is 2. The next one should be 3, but I won't say 3, 4. But I can't include 4. I can't include 4 because range would say n minus 1. So that's why I stopped at 0 and 2. And then this other one, the minimum of I, comma, I plus the batch size. So what is I? The first thing we are picking is 0. I is 0. So I slash the minimum of what is I? I is 0, comma, what is I plus the batch size? The batch size is 2. We assume that the batch size is 2, meaning that let's pick it to 2. Let's pick the rows 2 in 2. So we pick 2. So in other words, we have 0, 0, 0, so the minimum of 0 and 2 is 0, so 0 slice 0 is still 0, and then we'll say x train of 0. So let's pick 2. Let's assume that I is 2 because it will still even get to 2. So when I is 2 in this case, so we'll have I is 2, right? Then dot the minimum of I and I plus 2. So the minimum of, now I is 2 now, so this will be 2, and then I plus the bar size 2 plus 2, because the bar size 2 is 4. So the minimum in this case is 2. I think there's an error somewhere. Can I rub out this place, Joy, so I can use the whole place for this loop? Messi, are you there? Joy, are you there? Can I rub out this place so I can use the whole loop? Can I rub out this place so I can explain better using the whole? I'm saying, can I rub out this board so that I can draw this loop clearer so you can see it. You can see how it is working. Can I?
Yes, please go ahead. Yes, please
Okay.
go ahead. However, it's not everything I fully understand.
Okay, so let me know what you don't understand so I can come again. Just tell me what you don't understand.
Okay, so it's the beginning part. Because
It was the beginning part.
it was the beginning
I
part.
knew that at the time
I
you
knew
were
that
giving, I think
at the time you were giving, I think you gave an acronym.
Yes.
you give an acronym that had to do
You
with
give an acronym that had to do with
X, Y,
X,
Z. I
Y,
saw the acronym
Z.
ball.
I saw
All
the
through the time
acronym
you were
ball.
giving those
All through the
acronyms,
time you
my
were giving
screen
those
was frozen,
acronym, my screen was
Okay.
but I
frozen.
was just hearing it.
But I was just
Okay.
hearing it.
So everything I was taught before that
So
time,
everything I was
I
taught
think it was
before that
after you
time,
now
I think it was
logged
after you
in,
now
I was
logged
able to
in,
see
I was
the
able to
screen,
see the
and
screen, and now
I still had a little glitch.
I still had a little
I still had a
glitch.
little glitch in
I still had a
between.
little glitch in between.
Okay. So
My note did not really.
My note did not really.
It was when it got to bad
It was when
size,
it got to bad
and you were now
size,
picking them one by
and you were
one. The
now picking
acronym.
them
I
one
was
by
not kind
one.
of
The
okay
acronym. I was not
following.
kind of okay
Like, oh,
following.
okay, we'll
Like,
talk about
oh, okay, when we
slicing,
talk about
minimum and
slicing,
maximum value.
minimum and maximum
Because
value,
we've done something
because we've done
related to
something
that before.
related
I
to
was
yes.
that
kind of
before.
been able
I
to
was kind of been able to
follow.
follow.
Okay. So you mean I should start from here, this part here, right? From this for I in range of 0, x shape and batch size. Is that where you want me to start from?
Yes, and the beginning of
Yes, and
that
the beginning
acronym,
of
like the
that acronym,
explanation too.
like the explanation too.
Okay. So this is your data, right? So we have 4 rows. If you check the shape of your data, we have 4 rows, and the shape of your X train is 4 rows and 2 columns. The shape of your Y train is 4 rows and 1 column. So to start training your network, you need, at least to start with, you need this Molin XYB. M is the model, O is the optimizer, it has your learning rate, right? Am I recording? Yeah, it has the learning rate. L is the loss function. L is the lambda that is added to the regularizer. N is the number of epoch. X is the X train, Y is the Y train, and B is the batch size. All of these are needed, right? So I started with, okay, first just put maybe a loss variable that will take in values, because this will be needed. And for I in range in the number of epoch, the first thing we're using is the number of epoch. That is how many times you want to be going downstairs and coming up. I can say for I in the range
Sir,
of,
are you
am I
writing on the
what?
screen? Are you writing on the screen? I can't see anything. I can't see anything.
I I'm not writing yet. I'm just. But can you see my screen?
Yes, I can see your screen. Yes, I can see your
Okay.
screen.
So I'm not
I just
writing.
wanted to be sure you are right. I just
I'm
wanted
not
to be
writing
sure
here. I'm
you are
just
right.
saying when you pick, the first thing we pick is the number of epoch. How many times you want to be going? You want to go up from down. So if I'm saying I'm going up, I'm going. I want to go up down 10 times. So I can just write 10 here, but I'm not writing 10. I'm defining a function. So I'm saying that, okay, let me say it is n, because later on I'm going to define what my n is. I can say n is 50. So I'm just designing a framework now. So n is the number of epoch. My train loss, we are starting from 0 because from the beginning I don't have any loss. And then I'm saying model then train, letting my model understand that, okay, fine, what we want to do now is to train. And remember, so instead of doing all of this, doing it one after the other, I want to use a batch size because because of computational cost. I want to do it in twos. I'll pick the first two and then I'll pick the last two. That's what I want to do. So I need to create a for loop. Is Messi back? Do you think Messi is back?
Yes.
Okay.
Yes.
So I want to do a for loop. So the first thing I'll do is I'll say for I in what? 0. Start from 0. 0 means start from 0. 0. Then x train dot shape. So the shape is 4, 2, but I can't use the whole shape. I just need the row. So I'll say x underscore train, which is this x. I can call it just x dot shape. I'll put 0. 0 is saying that pick what you have first here in your shape, and it is the row. And I'll say the batch size, which is b. So I'm saying I've used the number of epoch for the first for loop. I've used x for the second for loop. I've used batch size also. The idea behind this is, if you remember when you are picking your range, if I say what is the range, what is the range of 6? The range of 6 means start from 0, 1, 2, 3, 4, 5. Don't include 6. If I say what is the range of 7, it is 0, 1, 2, 3, 4, 5, 6. Don't include 7. But if I say what is the range of 0 to 6, it means 0 to 5. If I say 1 to 6, it means 1 to 5. You won't start from 0 because I already put 1. I can also say what is the range of 1 to 6, difference of 2. It means start from 1, end at 5, but difference of 2. Meaning 1, instead of saying 2, you say 3. Instead of saying 4, you say 5. You stop here. Because the next one will be 7, and you know it's more than what you have here. So the idea, this one now, the range of this to give us 135 is what I have here. So now let's assume that the batch size, I want to be picking it 2 in 2, 2. I want to pick the first 2 and then I'll pick the second 2. So my batch size will be 2 in this case. So I'm saying the range of 0, start from 0, x train. What is the x shape? The x shape is 4, which is the number of rows I have. So the number of rows is 4. End at 4, and intuitively you are not ending by 4, you are ending at 3. You know that when you are using range. But the difference of the batch size, so what is the batch size? I'm looking at 2. So meaning that if you are going to have this, you have 0, the next one should be 1, but it won't be 1 because of the batch size, because of the difference, which is 2. So you have 2. The next one should be 4, but you can't include 4 because 4 will not be included when you are looking at range. So you stop at 0 and 2. So what this will produce now, what this for loop will produce is 0 and 2. Do you get it? Do you get it?
Yes.
Okay.
Yes.
Good. So now, the next thing is to now define your features. How you want your features to be. The features are the independent variable. I will soon round up the class because it's already 9:30 and it's past 9:30. Don't worry, we'll take it bit by bit. I don't know, maybe we'll find another time on Thursday to finish this thing. And the reason why it's taking time is because I'm breaking it down so you can. I don't want to. I can just go to Python now and code all of this, but I want you to understand why is this working. So the features are the independent variable, and then you need your dependent variable, how you want it to be. So there's a way you define your dependent variable and independent variable. So and how do you define it? Remember, this if you are remember these are the independent variable x1 and x2, and dependent variable is y. So how do you define it? So we say that x itself, which is this or this, but it's x string, but let's just use x because it's x that is here. So x, right? X of what? If I say x of 0 will give me the first column. If I say x of 1 will give me the first column, second column, right? So this is like when you are doing is it indexing? Yes, indexing. So x of what? So I'm saying x of I want to slice it. Remember, what are the i's? The i's are 0 and 2. From this, we have picked it from here 0 and 2. These are the i's. And the minimum of x and I plus the batch size, which is b. And what is y? Y is I and the minimum plus y and I plus b. So let's pick each of them one after the other. The first one, when I is 0, we'll pick when I is 0. So let's start from when I is 0. So what do we have? We have x 0, the minimum of what is x? What is the x string that we have here? The shape we have here. So minimum of 4, because it's 4. Remember, this is 4, right? 4. Minimum of 4 and I plus batch size. So I is 0. 0 plus batch size. Batch size is 2. So what do you have here? You have x 0 and minimum of 4 and 2 is what? Is 2. Meaning that you are picking x. You are starting from 0. You are slicing from 0, 0 and 1. So you are slicing from 0 and 1 because 2 will not be included. 0 and 1. So you are picking x 0 and 1. So you are picking this x here 0 and 1, which is intuitively that's what you are picking, right? And then for y, when y is 0, what do you pick? Let's go. So y will be what? Y is I is 0, 0 and the minimum of what is I? What is y? Y in this case, what is y shape? Y shape is what? Y shape is 4, 1. So we are picking 4, the first one. So 4, right? 4 and 4 and I plus batch size. I plus batch size is 2. Right? I plus batch size is 2. So meaning that we have y 0 and the minimum of 4 and 2 is what? The minimum of 4 and 2 is 2. So pick 0 and 1 for y. So you have your y, pick 0 and 1, which you only just pick this in this case. So I haven't done that. If you say when I is 2 also, so this slicing, I've explained slicing, but I think so. Can you see this?
It is Joy, no. It is Joy, no.
Let's look at this, right? Joy, can you see my screen? So let's quickly just do this and end the class.
No,
You cannot.
No, I can't see it.
Oh,
I can't see
okay, so
it.
let's quickly do this to end the class. So Mercy, let's work together with this so we can get it. So we already know that x is 0 and 2, right? I is 0 and 2. So what is the let's say when I is 0, what is our feature and our dependent variables? I is 0. So let's put everywhere we have I and the bad side. So what do we have? Mercy, let's work together. I'll meet yourself. So I will be what? Yeah, sorry, please. I'm still in my meeting. I'm so sorry. I'll soon be rounding off. Yeah, I'll soon be done.
Okay.
So Mercy, let's work together.
Okay.
0.
I is 0. Okay.
So minimum of
I is 0.
0 and what? Minimum of 0 and 2. So the answer should be what? No, not 0 and 2. This is 4 and 2. 4 and 2. X is 4. The shape of X train is 4, right?
Okay.
Yes. So minimum of 4 and 2 should be what? Should be 2. Right?
True.
Good.
Yes.
Okay. So
Yes.
I will explain it. Don't worry. Just let's. So what of the feature? Feature will be y and the same thing 0 and 2. So when I is equals to 2, that's the next thing, right? So the feature will be what? The feature will be x2 and what? Minimum of what? I is 2 now. So the x shape is 4 and 2 plus 2. 2 plus the bad side is 4, right? So minimum of 4 and 4 is still 4, right? So we'll have 4. And then dependent will also be y 2 and 4. So with this, we'll be able to pick our batch size. This will help us pick our batch size from our data set. So remember, this is how our data set looks like. It looks like 1, 2, 3, 4. So let's say x is 0 and 2. So x is 0 and 2, it will pick 0 and 1. So meaning that pick the first, so it's going row wise. Sorry, I said column wise. It's going row wise. So the first row is this, row 0 and row 1. So it will pick this 1, 2, 1, 1. And for this feature y0, 2, so this is y. It will pick the first one and the second one because it's 0 and 1. So y is 0, y is 1. That's what you have here. And then for the second case, when it's going for the second case, 2 and 4. So 2 will be what? It will be 2 and 3. So when x is 2, this is 0, this is 0, 1, 2. So x is 2, it will pick this, and 2 and 3, so it will pick this one. So x will pick 1, 1, 2, 4. And then for D, 2 and 4 will pick these 2. So you can see we have splitted it into 2 batches. This is batch 1, and this is what? Batch 2. So we'll continue because time is fast spent. Time is already 9:44. We'll continue. I think we have to look for one day again to just finish this up.